This is task 2, question 1 from page 7 of the Digital Electronics course notes. In this question, we've been given a circuit that has 2 digital logic gates, and we are asked to find Z, but to do so we'll need to find the values at point C in the circuit first. In order to solve a problem like this, we start with a standard layout for the number of inputs that our system has. Well, we can see here we've got 2 inputs, A and B. So I've taken the first 2 columns for a standard truth table with 2 inputs from page 5 of the course notes. Now we can see in this question we're going to need to work out what C is, and we're going to be finding out what Z is as well. So I'll add those 2 letters as additional columns in our table as well. We'll be getting values for both of these. Now, how we tackle a problem like this is by considering each logic gate in turn from the beginning of the circuit. So I'm going to start off by looking at this NOT gate here. I'm putting it in a red box to identify it. And this gate is a NOT gate, and what it will do is it will take whichever value is put into it and give us the opposite value. So a 0 becomes a 1 and a 1 becomes a 0. So we can take every row in our table in which we have 0 for A and put a 1 in the C column. So this very first row here, we see it's A is 0, so we put a 1 in for C, and the same in the second row as well. And in the third and fourth row, well, we've got a value of 1 for A, so we put in the zeros for those 2. So that's how we find our values for C, by considering each value for A and putting the opposite in. And we needed to find C because the next gate we're going to look at is an AND gate, and its inputs are B and C. So I'll put a blue box around this to identify it. So this is an AND gate. Now the rule for an AND gate is that both B and C, the 2 inputs, will need to both be 1 to give us an output of 1 for Z. That's from just the standard truth table for an AND gate. So let's look at each column in turn, and I'll mark a blue arrow at the top of the 2 we're looking at here, because B and C are our inputs. Well, first row, B is 0 and C is 1, so not both 1, so Z is 0. The second row, B is 1 and C is 1, which is the 1 condition in which will give us a positive output, so Z is 1 here. The next row, we have B0 and C0, so that gives us a 0 for Z. And lastly, we have B1 and C0 again. They're not both 1, so we get 0 in the Z column here. So that's how we'd go about constructing a truth table for C and Z in question 1 of task 2.